Los, alohas. All right, here we go. Particle motion. Remember, the goal here, and I forget to say it sometimes, is to hit pause before I go over these problems and see how well you can do on your own. All right, 2019. And remember, you can always get it yourself, a little bit bigger. If you just Google it, it will come right up. But make sure you're trying it on your own. All right, you guys. All right, so we have the velocity of a particle. It's moving along the x-axis, and it's given by the differentiable function. Remember, if it's differentiable, then that means it's also continuous. All right, they give us a table above, and velocity is measured in meters per hour. T is measured in hours. Selected values of the velocity are shown in the table. The particle P is at the origin at time t equals 0. So that means its position is at 0 at time t equals 0. I justify why there must be at least one T. Right when I see that ding, 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 MVT, right? Justify why there must be at least one, and then they take a derivative that equals 0. Ding, 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 100% MVT. So I start this by writing since, okay, V of P is differentiable, okay, on the start with continuity, right, is continuous on the closed interval, okay, and differentiable on the open. Remember, if you have this statement down pat, when it comes up in a free response, you're golden, all right? The MVT guarantees guarantees, okay, that it's a value C, that's going to be in between these two guys, such that, all right, now you need to know the formula for the MVT. And what is the formula? That the velocity at 2.8 minus the velocity at 0.3 all over 2.8 minus 0.3 has to be equal to the derivative, right? And what are they asking us to do here? That the derivative is equal to 0. So if you set all of that stuff up right there, you are 100% good to go. I'm looking at my little answer key right now. Okay, and so if you do all of this stuff, it appears, let's see, we get 55. Yeah, we get 55 minus 55. And you find out that it actually does equal 0. So if I'm able to show that the I rock is equal to the A rock, I'm good to go. And what would that be worth? That would be worth 2 points, right? Because that'd be 55 minus 55 is 0. And if you write out the statement, you are just golden monies, you guys. All right, here we go. Part B, use a trapezoidal sum. So trapezoidal sum means you write out the area of a trapezoid right off the bat. Okay, and they even tell me which intervals to do this. Oh, nice and easy Japanesey, right? So this is just 0.3, well, it'd be 1/2, 0.3, and then I just need the two heights, which are 0 plus 85. Okay, that's it. And then what's my next one? Plus 1/2, it'd be 1.7 and 1/3, so that'd be 1.4, and then my 2 would be a 55 and a negative 29. Plus my last one would be 1/2, and I'm only going to 2.8, so what would this difference be? That'd be 1.1 from 2.8 to 1.7, and then it'd be a negative 29 and a 55, and if I do all of that correctly, you get 40.75, and that'd be 2 points. Oh, snap! Class, that was just worth 1 point. So right now you would be 3 out of 3, ready to get that 5 on the AP exam. All right, that means C and D are worth a lot of points. They're worth 3 points apiece. All right, part C. They introduce a second particle Q. This time, though, they give us a function for it. So that means I'm going to put that into Y1. Meters per hour, it's a velocity. Find the time interval during which the velocity of Q is at least 60 meters per hour. Find the distance traveled by particle Q during the interval when the velocity of Q is at least 60. All right, now I'm not going to get my calculator out and show you guys this, but what I want you to do is do this in your calculators and you should get it right. Y1, I'm going to put in 45 square root of x cosine. Remember, you don't have to use t when you're using your calculators, so everybody plug that in y1. Now for y2, you're going to plug in 60. All right, now when you graph these things, now think about it. I'm going to change my window from 0 to only 4. Okay, now I'm going to go as high as 60. So even though I'm from 0 to 4, hopefully I'm from 0 to 100, right? And then you're going to get your graph, and you're going to graph a line here at 60, and you just want to know from where to where is the graph above. And if you do it all correctly, it says right here in my notes that the answers should be, this answer right here would be, I'll call it A, I'll call this B. Remember, you store it. So we're going to let A equal, I got 1.866181. Make sure you got that. If you don't, come in and see me for help. B is 3.519174. And make sure you're getting those, right? And then what does it ask? It asks for the distance traveled. Well, if I want to know the distance traveled, right, class? That is simply displacement. So that would just be the integral from A to B of this Q function right here. All right. And then that gives me an answer. They have using the absolute value there, but I don't have to use the absolute value, right? Because it's all above. Okay. But if I did want to know the total distance, right, that would be the same as the distance traveled during that time period, which would be 106.108754. And that would be worth 3 points if you were able to get all of that correct. All right, part D. Part D is at time t equals 0, particle Q is at position -90. Using the result from part B and the function velocity of Q from part C, approximate the distance between particles Q, P, and Q at time t equals 0.8. Now I'm going to have to just look at my answer key here so I know my answer from part C, B, and C. All right, so first off, what I'm going to do is I'm going to do a position for P. And when I do a position for P, I want to know where that dude is at 2.8, right? I want to know where his exact position is. Likewise, I want to know the position of Q at 2.8. And if I know both positions, I would know how far away they are from each other, right? And that's what we're trying to do here. Well, hopefully you know that in order to do this, you need to know your position at 0, right? Your position at 0 of both of these guys, plus your displacement from 0 to 2.8. And this would be of P, right? That's going to give me displacement. This here would be for Q. Okay, and I'm going to get answers for these guys. This top one, we already did all the work, right? This was 0. This was, and I'm looking back at my answer, 40.75. So that's exactly where that dude is, right? No absolute value. When I want to know where we actually are, we need to know not total distance, but total distance, we need to know the displacement. Now, xq of 0, be very careful. That was -90, right? There was an initial condition, and then you're going to add that, and if you do all that correctly, you get 45.93765 tree. All right. I'm not sad. I'm happy. All right. And so how far away are they? You would say they're about 5, 5 and some change away. You use your calculator to get that. You want to know your exact answer. You subtract those two. What do I got? 5.188 or 5.187, depending if you truncate or if you round. All right. Hopefully feeling pretty good about that. If I go 2019, 2018, 2017, 2016, they all have particle motion, velocity, position, acceleration. So you got to be good at these guys. All right. Remember to hit pause like I'm going to do to get my answers up. And hopefully you're trying this on your own. All right, here we go. Let's get rolling. They give me a function here. It's got a sign in it. It's got a trig. So that means I better make sure I'm in radian mode. First question here, right? I'm going to plug this in y1. And it asks me to find the acceleration. Well, if I have that in y1, this is simply just v prime, right? V prime of 3, right? That would be a of 3, which would be a math 8 question. Make sure you guys math 8 this bad boy, and if you do it all correctly, you should get negative 2.118 as your answer. That would only be worth 1 point. Okay, it says, next question says, find the position at time t equals 3. Well, for part B, right, in order to find your position, which is x of 3, I need to know where I am at x of 0, and then I just need to know the displacement. Okay, that's it. And x of 0 right there, there's an initial condition, you're at 5. That's a math 9 question. And if you do all of that correctly, right, you don't even have to do any of it by hand because it is a number 2. You get an answer negative 1.760. And sweet, that was worth 3 points. So let's be honest, nice and easy, jab on easy, right? I should be 4 of 4 right now. Once again, so important that you're able to get these answers on your own. All right, C, they asked me to evaluate both of these guys, and they're asking me to say what it means. Hopefully you know right now, displacement, total distance. So that's it. And guess what? These are just calculadoras. So I'm going to give you the answers. This answer here was 2.844 or 3, depending if you round or truncate. This is 3.737. Boom, boom. So here we go. Let me give you the reasons. This right here, you should say, is the displacement of the particle over the time period from 0 to 3.5 seconds. This is the total distance of the particle over the time interval from 0 to 3.5 seconds. That was worth, oh my gosh, 3 points. Let's go. Give me them toes. All right, part D, the second particle moves along the x-axis with this position. So now they give me the position. Okay, at what time are the two particles moving with the same velocity? So I want to know when this guy's velocity is equal to that guy's velocity. So I'm going to find the velocity of my second dude, which is just 2t minus 1. I'm going to set that velocity right there equal to v of t from up here. I'm going to fix my window from 0 to 3.5, and then I'm going to find that they intersect, or they share the same exact velocity at 1.57054. I'm going to get the last 2 points of this problem, and I'm going to get a 9 out of 9s. All right, problem done. That's it. 9 out of 9. All right, let's keep rolling. We got 2 years to go. How about it, right? We don't skip years in this. So we can almost predict for 90% prediction rate, I would say, that there's going to be a particle motion on our test. All right, let me hit pause so you guys can hit pause and try this, and I can get my answers at. See ya on the flip side. All right, really hope you guys tried it. Okay, let's go here. Two particles move along the x-axis. We got particle P, we got particle Q. This is number 5 though. Darn it, I wish I said it before that pause, but I'm sure you guys are with it, right? So that means no calculator for this one. All right, I want to know when particle P is moving left. In order to know when particle P is moving left, ding, 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 I need to know when velocity is negative. In order to know when velocity is negative, I better find velocity, which happens to be the derivative of position, which is a chain rule, which is one, don't you dare touch the inside. But then I'm going to have to take the derivative of the inside, which is 2t minus 2. And I want to know when that's equal to 0 because I'm going to need some critical points. And I'm actually going to put it up here because I have a feeling I might need it later on. All right. Now, my critical points would be whenever the derivative or velocity is 0 or dne. Well, velocity is 0 when t equals 1 for sure. Now, what a lot of students forget is I should set the bottom equal to 0. Now, that bottom, it's not factorable. The AP is not going to make me quadratic formula on a number 5 where I have to show work. So the bottom can never be 0, which would give me a dne, right, you guys? All right. So now I just have to plug in values here. Well, let's plug in a 0 because that's to the left of 1. And if I plug in a 0, I get a negative 2 over a 10, which is a negative. If I plug a number bigger than 1, like 10,000, I get a positive divided by a positive. So I would say this is moving to the left, 0 to 8 from 0 to 1. And make sure you write y. And you should write because v of t is less than 0. Make sure you write that out. Okay, you guys, that right there, you would get 2 points for getting the answer correct. Part B. Find all times when the particles move in the same direction. Gosh darn it, I just said how much I didn't want to erase this, but it's easy peasy, right? Negative, positive. All right, so now I've got to go ahead and find, oh, sweet, that's already velocity. So I just got to factor that bad boy, spling, spling. So on that sign analysis, I'm make sure I don't erase it this time. You get a 3 and a 5. Whenever it looks like that, it's always plus, neg, plus, and I want to know when they're in the same direction. So they'll be in the same direction when they're both negative or they're both positive. They're both positive from 1 to 3 and union 5 to 8, right? Let me make sure that I get it right. Sweetie sweets, 1 to 3, 5 to 8. And you want to say that both velocities of P and Q have the same sign. All right, let's keep it. That was worth 2 points. Okay, I'm going to keep that there in case I still need it. Here's parts C and parts D. Find the acceleration of particle Q at t equals 2. So acceleration would be the derivative of velocity. So it would be 2t minus 8. And the at time t equals 2 would be 4 minus 8, so it would be negative 4, which would be less than 0. Now, why am I writing less than 0? Because I saw out of the corner of my eye that I'm going to have to say if q is its speed is increasing or decreasing. And we know to do that, we compare acceleration with the velocity, and the velocity at 2 is, and guess what? I can just notice right here. Remember, velocity at 2 is greater than 0. So since they are different signs, I would say that the speed of the particle Q is decreasing. And make sure you write down because it says to explain acceleration and velocity have different signs at t equals 2. All right, find the position of Q the first time it changes direction. Gosh darn it, I erased it again. But remember, the velocity sign analysis was a 3 and a 5. It first changes direction at 3. So I want to find the position of particle Q at 3, which means I need to know its position at 0, and then just displace it, right? And then just find its displacement. Okay, which it's a number 5, so I got to do by hand. All right, so where am I? Oh, sweetie sweets. I'm at 5 right there. I got to find the antiderivative of this, which would be 2 to the third over 3 minus, what would that be? 4t squared plus 15t from 0 to 3. Remember, you plug in the 3 first. A 3 in there is 27 over 3, which is a niners. A 3 in there is 9 minus 36. A 3 in there is a 45. And I'm going to subtract 0 minus 0 plus 0. Sweet, sweet. If you do all of that correctly, you should get an answer of what is that? 50, 59. I think I get 59.23 as my answer. That is where I am at the first time. Q changes the direction. That was worth 3 points, that last piece. Awesome. All right, last one of the day. Let's all hit pause so I can get my answer and you can try the problem. All right, here we go, you guys. Let's finish this off. It is a calculator question. Boom, it's right there. So here we go. At time t equals t is the particle speeding up or slowing down. Remember, if I want to know if it's speeding up or slowing down for part A, I've got to know what V of 4 is, and I need to know what A of 4 is. And this is all a calculator one. Okay, so hopefully you did pause it and you tried it on your own, and I get greater than 0 for the velocity at 4, and for acceleration, which is the derivative of velocity, I get something less than 0. So then you make the conclusion that this is slowing down, and it's slowing down because velocity and acceleration have different signs. And make sure you write that reasoning down, okay? Here we go. Part B, find all times t when the particle changes direction. Well, how do I know when it changes direction? Whenever velocity changes sign. So guess what? You can just graph this. And if you graph it, you want to know when velocity is 0. And velocity will be 0 at 2.707468. And then if you look very carefully, it changes from positive to negative at that value. So it changes direction at 2.707468. And you know what? You want to write stuff down because when you write stuff down, it helps the greater you know exactly what you're thinking. Because for a question like that, your calculator could sure do a lot of the work for you. All right, part C, find the position when we're at 0. Position would be x of 0, right? In order to find x of 0, you need to know your initial position, but then you're going to do your, find the position of the particle at time t equals 0. Whoa. And they give me that at time t equals 4. So here we go. We got to find this. And guess what? My initial condition is x of 4. So what am I going to do? I'm going to go backwards, right? And that's all you would have to do for this one. Little bit different from a lot of the ones that we've been doing though, right? X of 4 is 2, so you get that. And then this, right, it's a number 2, so it's just a little plug and chug. And if you do it correctly, you get negative 3.815. All right, and that was worth 3 points if you were able to figure that out. And then last but not least, should be the easiest one on here. I really hope so. It says total distance of the particle, which is simply from 0 to 3. Just don't forget that absolute value symbol. And if you do it, you get 2 points. If you get 5.301, donezo. Problem finished. Keep on working hard. Keep on finding problems to do on your own. Aloha.